In the pale light before memory, when the young earth still glowed with the heat of its making, something stirred in the silence between cooling stone and rising steam. 4.5 billion years have passed since molten rock first hardened into crust, since the first rain fell upon a world that knew no witness. And in all that immense corridor of time, through eons we can scarcely imagine, the planet has been doing something we might call thinking, though not in any way we would recognize, not with neurons or circuits, not with anything we could point to and name. The early atmosphere hung thick with carbon dioxide and methane, veiling a sun that burned 30% dimmer than it does today. Lightning crackled through volcanic plumes. The oceans, where they had begun to form, were warm and dark and restless, stirred by tides pulled by a moon that hung much closer in the sky. In those waters, chemistry was performing its slow experiments, combining and recombining the elements that stars had forged and scattered across the cosmos. The question drifts upward, like heat from volcanic glass. Could awareness have flickered here before, in forms so different from our own that we would never find their traces? Could intelligence have risen and faded in the deep past, leaving only the faintest chemical whispers in stone that has since been folded back into the mantle, recycled through the patient machinery of plate tectonics, erased by the very forces that made this world so dynamic, so alive? We stand at the edge of a thought experiment tonight, one that asks us to consider not what we know, but what we cannot know, and whether the absence of evidence might itself be a kind of answer. The dawn light strengthens now over an ancient ocean, and somewhere beneath its surface, the first stirrings of complexity are taking shape in ways that will not fossilize, will not endure, will not survive the grinding passage of geological time. The stone remembers heat. It does not remember what the heat illuminated. Perhaps the question is not whether intelligence arose before us, but whether we would even recognize it if the evidence had somehow survived. Perhaps the real mystery is not the possibility of prior minds, but the humility required to admit how little of Earth's long story we can ever truly read. We peer backward through billions of years, and the view grows dim, then dark, then silent, not because nothing happened, but because the recording medium itself has been overwritten again and again by the restless planet that never stops remaking itself. The light settles into morning, and the inquiry begins. The geologic record tells a story of transformation so vast that human history vanishes within it like a single breath in a hurricane. Scientists believe the Earth formed approximately 4.5 billion years ago from the same swirling disk of dust and gas that gave birth to our sun. For hundreds of millions of years after that coalescence, the surface remained largely molten, bombarded by debris from the still-forming solar system, too hot and violent to preserve any lasting structure. Evidence suggests that by roughly 4 billion years ago, the crust had cooled enough for liquid water to pool in low places. Tiny crystals of a mineral called zircon, found in the ancient hills of Western Australia, carry within them chemical signatures that some researchers interpret as hints of that early ocean. These crystals are among the oldest materials ever found on Earth's surface, survivors of almost unimaginable spans of time. Most geologists place the emergence of the first stable continental crust somewhere between 4 and 3.5 billion years ago, though the exact timing remains a subject of careful debate. The earliest convincing evidence of life appears in rocks dating to roughly 3.5 billion years ago. Stromatolites, layered structures built by communities of microorganisms, have been found in ancient formations in Australia and South Africa, their dome-shaped profiles preserved in stone that has survived the slow revolution of continents. Some researchers propose that chemical traces in even older rocks, perhaps as old as 4 billion years, might indicate biological activity, though such claims remain contentious. What seems clear is that life emerged relatively quickly in geological terms, within the first billion years of Earth's existence. The noon sun hangs steady over shallow water where the first cells divide. But here is where the story grows strange, where the comfortable narrative of progress begins to fray at its edges. The Earth's surface is not a passive archive. It is a recycling system of extraordinary power. Plate tectonics, the slow drift of continental plates across the mantle beneath, continuously creates and destroys the ocean floor. Almost all oceanic crust older than about 200 million years has been pulled down into subduction zones, melted, and reformed. The rocks that might have recorded the earliest chapters of Earth's history have been largely consumed by the planet's own geological metabolism. Continental crust fares better, floating above the denser material beneath like ice on water, but even these ancient rafts have been repeatedly heated, compressed, metamorphosed, and eroded. The oldest surviving rocks on Earth date to roughly 4 billion years ago, but they are fragments, scattered survivors of processes that have transformed and destroyed far more than they have preserved. This means that if anything complex existed in the first billion years of Earth's history, anything that might have assembled itself into patterns we would recognize as organized, as purposeful, as aware, we would be extraordinarily unlikely to find direct evidence of it. The stone does not keep such secrets well. The planet writes over its own past, draft after draft, preserving only scattered pages from an immense library that has been burning continuously since the beginning. Yet, what might we look for if we chose to look? In 2018, 2 scientists, an astrophysicist and a climate researcher, published a paper that approached this question with deliberate care. They did not claim that prior civilizations existed. They asked instead whether we could detect them if they had. Their thought experiment, named playfully after a fictional species from a television program, examined what traces an industrial society might leave in the geological record over spans of tens or hundreds of millions of years. The researchers began by noting that humans have existed in our current form for roughly 300,000 years, but our industrial phase, the burning of fossil fuels, the synthesis of plastics, the splitting of atoms, has lasted only about 3 centuries. This is a geological instant. If a similar civilization had risen and fallen at any point in the previous hundreds of millions of years, how would we know? The answer was sobering. Most artifacts would simply vanish. Plastics, metals, concrete, the physical evidence of our own civilization, would erode, dissolve, and disperse over geological time. What might remain would be subtler. Anomalies in the ratio of certain carbon isotopes, suggesting the burning of fossil fuels. Unusual concentrations of synthetic chemicals that do not occur naturally. Perhaps traces of radioactive elements from nuclear processes. But even these signatures would fade, blur, and become increasingly difficult to distinguish from natural variations over millions of years. The researchers noted that less than 1% of the land surface that exists today dates from before about 2.5 million years ago. The vast majority of Earth's surface has been recycled, reshaped, buried, or transformed multiple times since then. Finding artifacts from tens of millions of years ago would be like finding a particular grain of sand that had been through 1,000 storms. The researchers noted something even more humbling. For most of Earth's history, the surface conditions were so different from today's that any intelligence arising then would have faced utterly different challenges and opportunities. Before roughly 2.5 billion years ago, the atmosphere contained almost no free oxygen. The energy sources, the chemical possibilities, the very building blocks available for complex organization would have been fundamentally alien to anything we know. Any intelligence from that era would have been shaped by conditions we can barely imagine. Dusk settles over the ancient shore, and beyond what the data can show, beyond the careful hedging of peer-reviewed science, there lies a quieter realm of contemplation. It may be more honest to imagine than to assert, to hold the question gently rather than grasp for answers the evidence cannot provide. Consider what intelligence might mean in contexts so different from our own. We tend to think of mind as something that emerges from neurons, from the particular architecture of biological brains that evolution assembled over hundreds of millions of years. But some researchers propose that the essence of mind, the capacity to process information, to respond adaptively, to model the world and anticipate its changes, might arise from many different substrates, many different arrangements of matter and energy. The boundaries of what we call intelligence have grown fuzzier as we have studied them more closely. Slime molds solve mazes, plants communicate through chemical signals in their roots, bacterial colonies coordinate their behavior in ways that resemble decision-making. None of these involve neurons or brains as we understand them. They remind us that nature has found many paths toward adaptive complexity, many ways of processing information and responding to challenges. The silence between epochs holds its questions. The Earth itself could be imagined as a kind of thinking system, though not conscious in any sense we would recognize. The slow circulation of the mantle, the feedback loops between atmosphere and ocean and rock, the way the planet maintains conditions that allow liquid water to persist on its surface across billions of years. These could be seen as a form of planetary cognition, a vast and distributed intelligence that operates on timescales far beyond anything a human mind could perceive directly. James Lovelock and Lynn Margulis proposed something similar with their Gaia hypothesis. Not that the Earth is literally alive or conscious, but that living systems and geological systems are so deeply intertwined that the planet behaves as a single, self-regulating entity. The composition of the atmosphere, the salinity of the oceans, the temperature at the surface, all these have remained within habitable ranges for billions of years, despite massive changes in the sun's output and the planet's geology. Something is maintaining stability. Something is correcting perturbations. Whether we call it intelligence depends on how we define the word. Perhaps the planet was practicing, all those billions of years, before life as we know it assembled itself from the available chemistry. The first stars had scattered their heavy elements across the cosmos, and from that scattering rocky worlds condensed around younger suns. Carbon, nitrogen, oxygen, phosphorus, the atoms that would eventually build proteins and nucleic acids and cell membranes, were present from the beginning, floating in the primordial soup of the early ocean, organizing and reorganizing in patterns that chemistry permitted but did not require. Hydrothermal vents on the ocean floor pumped mineral-rich water into the darkness. Some researchers believe these vents provided the energy gradients and chemical conditions necessary for the first complex molecules to form. Others point to shallow tidal pools, where the cycling of wet and dry conditions might have concentrated organic compounds and driven reactions that would not occur in open water. Still others suggest that life's building blocks arrived from space, delivered by comets and meteorites that had been cooking organic molecules in the cold laboratories of interstellar clouds. The truth may involve all of these possibilities, and others we have not yet imagined. Some scientists believe that the boundary between chemistry and biology is not a sharp line, but a gradient, a continuum of increasing complexity. Simple molecules combine into more complex ones. Complex molecules form networks of chemical reactions that can sustain themselves, that can copy themselves, that can change over time in response to their environment. At some point along this gradient, we begin to use the word life. But the transition may have happened gradually, through stages we cannot reconstruct, leaving no clear marker in the rock. The current gathers in darkness. And if chemistry can become biology through such subtle transformations, might it also be possible that organization, pattern, something like awareness, could emerge and fade in forms we have no categories to describe? The Earth has been experimenting for a very long time. Most experiments fail. Most innovations vanish without trace. But the failures, too, are part of the story. The countless trials that preceded every success. The roads not taken that we will never know existed. Consider the Ediacaran period, roughly 600 million years ago, when strange, soft-bodied organisms flourished in the shallow seas. These creatures, if creatures they were, left impressions in the sand that look like nothing alive today. Quilted fronds and segmented discs and fractal spirals, they populated the ocean floors for millions of years and then vanished, replaced by the more familiar forms of the Cambrian explosion. Were they animals? Were they something else entirely? Scientists still debate their nature, their relationships, their place in the tree of life. If such fundamental questions remain about organisms from merely 600 million years ago, how much more uncertain must we be about anything that might have existed in the first billion years, the Hadean and Archean eons, when the Earth was young and the geological record was being actively destroyed by the processes of its own making? The twilight deepens over quiet water. Meanwhile, in the stone that remains, in the surviving fragments of ancient crust, geologists find evidence of profound transformations. Roughly 2.5 billion years ago, the atmosphere began to fill with oxygen, a waste product of photosynthetic organisms that had learned to harvest energy from sunlight. This great oxidation event changed everything. It rusted the iron in the oceans, laying down vast deposits of banded iron formations that we mine today. It poisoned the anaerobic life that had flourished before. It opened new possibilities for complexity, for energy-hungry organisms that could burn oxygen and extract more power from their food. Some researchers have wondered whether this transition, or others like it, might hide evidence of earlier complexities. The Paleocene-Eocene thermal maximum, roughly 56 million years ago, saw a dramatic spike in global temperatures and changes in the carbon isotope record that are not fully explained by known natural processes. Could such anomalies hint at prior industrial activity? The scientists who proposed the thought experiment were careful to say no. The timescales are wrong, the signatures insufficient. But the question itself opens a door in the mind. The same wind that once carried volcanic ash now carries pollen. The same oceans that once steamed under a younger sun now hold the patient accumulation of sediment, layer upon layer, a record that grows thicker even as the oldest pages are pulled down into the mantle and erased. Night approaches and the questions grow softer. What does it mean to think about intelligence across such spans of time? Our own species has existed for perhaps 300,000 years. Our industrial civilization, the phase that leaves detectable traces in the geological record, has lasted about 3 centuries. This is a vanishingly small fraction of Earth's history, a flicker against the slow pulse of geological time. If we were to disappear tomorrow, how long would it take for our works to be erased? Millions of years, perhaps. Perhaps less. The planet has time to forget. When stone forgets its shape, does it still remember heat? The question is not really about prior civilizations. It is about the nature of complexity, the fragility of order, the relationship between mind and matter across the vastness of deep time. It is about humility before the unknown, and wonder at what the unknown might contain. Consciousness, scientists tell us, appears to emerge from complexity, from the intricate networks of neurons in a brain, from the feedback loops and recursive processes that allow a system to model itself, to anticipate, to choose. But we do not fully understand how this emergence works. We do not know whether consciousness is unique to biological brains, or whether it might arise in other substrates, other configurations of matter and energy. The Earth has been complex for a very long time. The atmosphere, the ocean, the slow cycling of rock through the mantle, these systems interact in ways that maintain stability over billions of years, that respond to perturbations, that correct and adjust and persist. This is not consciousness as we experience it, but it is a kind of intelligence, a distributed and geological intelligence that operates below the threshold of awareness. Perhaps, in imagining prior minds, we are really imagining ourselves seen from the future, asking whether anything of our thoughts and dreams and cities will endure, whether any trace of what we have built will survive the patient erasure of geological time. The answer is probably not, and that too is a kind of answer. The question turns inward now. from the cosmic to the personal. What does it mean to be aware in a universe that may have produced awareness many times before, in forms we cannot imagine, forms that left no trace? What does it mean to wonder about the past when the past has been so thoroughly erased? Perhaps it means that the wondering itself is precious, not because it will last, but because it exists at all. The universe has assembled, from hydrogen and time and the strange logic of physics, arrangements of matter that can ask questions about their own origins. That this has happened even once is remarkable. That it may have happened before, that it may happen again, that consciousness may be a recurring theme in the symphony of existence, rather than a single note. This possibility does not diminish our experience. It places us in context. The reflection of stars appears on still water. Oceans rose, continents wandered, time kept breathing. The same molecules that built the first cells have been reassembled countless times, passed from organism to organism, generation to generation, form to form. The carbon in our bodies was once in ancient microbes, once in the atmosphere, once in volcanic gas rising from the mantle. We are made of recycled materials, participants in a cycle that began before life and will continue after us. If intelligence arose before, it was made of the same atoms. If it thought with borrowed matter. If it built with materials that would eventually be reclaimed by the Earth's slow metabolism, folded back into the mantle, melted and reformed into new configurations, new possibilities, new experiments in organization and complexity. The night deepens, and somewhere in the darkness, the question rests without requiring an answer. The thought experiment has done its work, not by proving anything, but by opening a space for wonder, for the recognition of how much we do not know, for the acknowledgement that the universe may have been thinking about itself in ways we can never recover. We often imagine that we stand at the pinnacle of some great ascent, that the long story of Earth has been building toward us, toward this moment of awareness looking back at its own origins, but the story may be more like a river than a mountain, flowing, branching, sometimes doubling back, sometimes disappearing underground only to emerge elsewhere. We are one current in that river, not its destination. The mathematics of complexity suggests that self-organizing systems arise naturally wherever energy flows through matter in the right way. Crystals form, convection cells appear, patterns emerge without intention, without guidance, simply because the physics permits them. Some of these patterns are simple and static, others are dynamic and evolving, growing more intricate over time. At some point, the patterns become complex enough that we hesitate to call them mere chemistry. We begin reaching for other words: life, mind, awareness. Time exhales. The Earth has been breathing for 4.5 billion years. It will continue breathing after we are gone. Whatever patterns arose in the distant past, whatever flickerings of order and complexity the ancient world produced, they are part of us now. Not as ancestors, perhaps, but as predecessors in the long experiment of matter trying to understand itself. We share our atoms with everything that came before. The hydrogen in our bodies was forged in the Big Bang. The carbon came from the hearts of ancient stars. The iron in our blood was scattered by supernovae billions of years ago. We are made of the same materials as the earliest chemistry, the earliest organization, the earliest stirrings toward complexity that the universe produced. In this sense, we are continuous with whatever came before. The boundaries we draw between living and non-living, between aware and unaware, are useful for our purposes, but may not correspond to any sharp divisions in nature. The universe appears to be a gradient of organization, with patterns nested within patterns, complexities emerging from simpler substrates in a cascade that has been flowing since the beginning of time. When the first proteins folded, when the first cell divided, when the first organism sensed light or temperature, or the presence of food, at each of these moments was something new entering the world, or was something that had always been latent, finally expressing itself. The question may be more about our categories than about reality. There is something restful in this vision, the sense that nothing is ever truly lost, only transformed. The patterns that make up our thoughts will one day disperse, but the matter that carried them will persist, will combine in new ways, will perhaps carry new thoughts in forms we cannot imagine. The continuity is not personal, but it is real. We are part of something much larger than ourselves, much older, much more patient. And perhaps that is enough. We are not the first arrangement of atoms to wonder. We may not be the last. The wondering itself is the gift, the improbable flowering of consciousness in a universe that did not have to produce minds, but did. And in that wondering, we join whatever came before, whatever might come after, in the slow conversation of existence with itself. The darkness outside is complete now. No light remains on the horizon. The ancient questions have quieted into something softer. Not answers, but acceptances. Not certainty, but peace. In the end, we return to where we began, to the pale light before memory, to the young earth glowing with its own heat, to the silence between cooling stone and rising steam. Whatever stirred, there stirred for its own reasons, if reasons it had. Whatever patterns formed there, formed because the universe permits such patterns to form. We are made of the same permission. The stars wheel overhead as they have wheeled for billions of years. The same constellations that no eyes witnessed in the Archean now shine upon a world that has grown observers. The light that reaches us tonight left its sources before any complexity arose on Earth. We see into the past simply by looking up. And perhaps that is all the answer we need. Not whether intelligence existed before, but that intelligence exists now. Not whether the universe has been conscious of itself for billions of years, but that it is conscious of itself at this moment, through us, through whatever other minds may exist on worlds we cannot see. The question and the questioner are part of the same unfolding. The stone cools beneath the darkness. The wind settles. The tides continue their ancient rhythm, pulled by a moon that has been receding from the earth for 4 billion years, so slowly that no lifetime could perceive the change. Everything returns to stillness. The inquiry rests, and the earth keeps breathing. So do we.